In section 3.2, we're going to talk about linear functions. And so just some review of some vocabulary back from Algebra 1. The equation of a straight line written in the form y equals mx plus b is called the slope-intercept form. In the world of IB, instead of using the word slope, just a reminder once again, they will probably call it gradient intercept form instead of using the word slope. The equation of a straight line written in y minus y1 equals m times x minus x1 is called point slope. Or again, point gradients. The equation of a horizontal line with a y-intercept of c is just the line y equals c, and horizontal lines have a slope of 0. The equation of a vertical line with x-intercept of b, when we write vertical lines, we write x equals, and the slope is undefined. So here are 7 questions just to review some of the slope concepts and writing equations of lines. So I want you to try these questions, and then I'm going to put the answers up as we go. So feel free to work faster than I do. That's totally fine. I'll talk through some of them. So finding an equation of a line, I'm going to encourage you to use the point slope form whenever possible, because then you don't need to know a y-intercept. So that point slope form looks like this. Again, this is in your formula booklets as well. So when I look at this particular graph, I find 2 points, and I can see I have a rise of 4 and a run of 3. So my slope is 4/3. And then I can use one of those ordered pairs. This particular ordered pair was -3, -3. So I can put x minus -3 and y minus -3. So I get y plus 3 equals 4/3 x plus 3. And you can just leave the equation just like that. You can also put it in slope-intercept form since this one did have a nice y-intercept. So if you put it in slope-intercept, you would get 4/3 x plus b, and our b was 1. You would get that exact same answer if you did distribute this value out and subtract the 3 over. In number 2, it says to find the equation of the line with a y-intercept. That's nice. There's our b value. And then they tell us that it's perpendicular to the line y equals -7/2 x plus 6. So I first identify the slope of the line. If I'm trying to do perpendicular, we have to do the opposite reciprocal slope. So since this one was negative, I make this one positive, and then I flip the slope. So 2/7. So now I know my slope, and I know my y-intercept. So this one would be nice in slope-intercept form. So 2/7 x minus 4. Number 3 tells me to do an equation of a horizontal line that passes through 0, -2. Horizontal line is just y equals the number. Number 4 says to find the equation of a vertical line. So vertical lines, we put x equals, and all we care about is what this x value is. So x equals 3. Find the equation of a line with a gradient of 0, so slope of 0, and it passes through the point -7, 4. So I know that slopes of lines of 0 mean that we have a horizontal line. And a horizontal line is written in the form y equals a number. So in this case, I need to look. I've got x, I've got y. So this is the number I'm concerned with. So it's y equals 4. For number 6, it says to find the equation in point gradient form. Okay, so we're going to be using that point slope, which is up on the top of the screen. They give me a point, and they tell me it's parallel to this line. So parallel means same slope. So we're going to use negative 1/2. And we have our point at -4, 5. So we go y minus y1 equals m x minus x1. And we can just leave our answer just like that. Number 7 also asks for it in point gradient form. This time they gave me 2 points. So the first thing I have to do is get my slope, and I'm sorry, I don't have any room, so I'm going to write mine off to the side. I have to do the slope first. So -4 minus 2 over 3 minus -1. So we get -6 over 4, which reduces to -3/2. And now I can pick either one of these points to be my point for my equation. I'm going to use -1, 2. You can totally choose the other. So my equation here, y minus 2 equals m x minus x1. And there's my equation. The last part of section 2 has us digging into using our graphing calculators to find intersections instead of having to do solving systems of equations. So take out your graphing calculator, and what we're going to do is look at these equation pairs. So I've got -3x plus 1 and -5x plus 3. In our graphing calculators, you're just going to put those into y1 and y2. We're going to hit y equals, put this one into y1, and put this one into y2. So here's my graphing calculator. I'm going to put those functions in, -3x plus 1 and -5x plus 3. I'm going to just make sure I'm on a normal window, which I am not. So if you're not on a normal window, you can hit zoom and then just go to standard, which is number 6. Give myself a standard window. There's the first line. There's the second line. I can see that they cross somewhere in here. I'm going to make my calculator find that intersection by hitting second and then calculate, which is right above trace. And I want to find number 5, which says intersect. And then it's going to ask you about first curve versus second curve. Sorry, we've got a little bit of a glare there. You can see my cursor is blinking. Just move it as close as you can to the intersection. So I'm going to say, yeah, right there. Second curve, that looks accurate. Hit enter again. And then it's asking, would you like me to guess? Yes, please. So I hit enter again. And it says my intersection is at 1, -2. So my answer here would be 1, -2. You can do the same thing for these remaining 2 equations. This one you would have to put into slope-intercept form first, into y equals first. This one, notice they don't have any y equals in there, but they're telling you this equation equals this equation. This one's very easy to just solve by hand, like Algebra 1 style, but we're getting the practice with how to put these into our calculator. So this one would go into y1, this one go into y2, and find the intersections. Go ahead and do those, and then I'll put the answers up. All right, those are the answers. Check your work. Sorry, didn't mean to hit that button. So now we look at these real world examples on the next page. And so it says we've got a video streaming service that charges a monthly service fee of $6.99 per month and an additional 99 cents for each 24-hour download rental of a premium movie. The total monthly cost of this service is written as that function, where X is the number of premium rentals downloaded that month. So in part A, it says to find the total monthly cost for a month in which there are 5 premium movie rentals. And so we can see that our X value represents our number of rentals. So they're asking us to find f of 5. So we plug in 5. Go ahead and put it in on your calculator. And we see that we get a total of $11.94. For part B, they're telling us to find the inverse of f of x and tell us what the inverse represents. So inverse, we switch the x and the y. And then we solve for y. So there's my inverse. And so in this one, for the inverse, this represents the number of premium movie rentals that we can do in a month. And then in part C, it says to find the number of premium movie rentals downloaded in a month where the total monthly cost was $18.87. So X in this case represents our total cost. So they've given me the total cost. And we are trying to find the number of rentals per month. So go ahead and put that into your calculator. And I see that that gives me 12 movie rentals. The last section here is all about linear modeling, which you're going to need on your calculators. And it talks about using these tables to come up with a linear model for the function. And so it says, without plotting a graph, show algebraically that the relationship between the number of days and the cost is a linear relationship. So we just need to show a constant rate of change. So if I subtract 60/50 minus 30/25, I can see that it went up 30/25. We just want to see if that continues. And I can see, yes, I add $30.25. And then I add $30.25. So this represents our slope of this function. So it says to find a linear model for this relationship and to give our answer as a function in gradient intercept form. So I need to find the y-intercept. So on day 0, if I subtracted 30/25, I'd be down to 0. So that means all I have to concern myself with is the slope, 30/25x plus 0. And then it says find the cost of renting the car for 7 days. So y equals 30.25 times 7, which gives us 211.75. The last one is one for you to try on your own. this particular function? The answer is in your textbook. So I want you to try this example, and then you can check in your textbook to see if you got that one correct.